let's suppose you have cracked some exam and now you want to go to a institute. So now you will sort out the institute, right? Like you will be tending towards that institute from where good number of packages they have got. Okay, so let's suppose you have sorted out one particular college where you have seen that their mean package they have got is around let's say some 32 lakhs. Okay, whatever package, 32 lakhs per year. Now as soon as you have seen that data, your brain jumped. Okay, your there is burst of dopamines and endorphins in your chemicals that okay, this college has 32 lakhs of package. So if I go there, there's a good chance that even I might get somewhere around 30, 32, because the mean package is 32. Okay, so now you have gone to that college. Now after you went to that college, after all the studies and everything, at the end you got a job, and let's suppose you have got a job of 10 lakhs or 8 lakhs, 12 lakhs, whatever. So you have got around 10, 12 lakhs of package. Now you will be thinking, okay, what went wrong? Because I had seen the mean package was 32 lakhs, but I'm getting a package of around 12 lakhs, 10 lakhs. Okay, so what went wrong? What possibly could have gone wrong? So the thing is, you have seen the mean salary. Okay, so mean salary means what? Now let's suppose there are certain number of students in that same college. Let's suppose 10 students, and in that 10 students, 9 have got somewhere around 15 lakhs, 12 lakhs of package. I'm just taking random number. Only one person has got some, let's suppose 70, 80 lakhs. Okay, so now if you do the average of all of them, so one guy has pulled till 80 and others are in the range of 12, 15, 20 maximum. So overall if you see the mean, because that one guy is pulling up that side, the mean has shifted. The mean has shifted from this data, where this number of people were there, from here the mean has shifted upwards until let's say 30, 35. This is not a calculated value. I'm just trying to make you understand what is it. Okay, what is the application of statistics. So when you had seen that mean value, the mean value is around 32, that is the average of all. Okay, so in this, what was the problem? The problem was one person had got 80 lakhs. Because of that, the mean has been pulled that side, right? So that is why the mean, that's why you got confused. Okay, so the mean is 32, but this is not the true scenario, because none of the 9 students there, they had got more than 15 lakhs or 20 lakhs of package, but the mean is shown as 32. So that's not true. That's how statistics, the mean sometimes fools us. Okay, so we will begin with the chapter, the video lecture. So in this video lecture we will be trying to cover these many things. Okay, now to cover all these topics, if I feel this is taking too long, then I might have to cut in between and make it part 1 and part 2, because many of my friends have told that the lectures are going too long and the time span, what is that, the attention span is not so much. So if I feel this is going like 1 hour, 1.5 hour, then I will cut it down to, okay, maybe 30 minutes and whatever. So in this lecture we will be trying to understand what is central tendency. Under the central tendency we have the mean, median and mode, and this we already know in class 9th, 10th, 11th, 12th, all we have studied what is mean, median, mode. So we will not be spending too much time in that. We will be focused more on this particular part. This is dispersion. Okay, so what is the general meaning of dispersion? Dispersion means what? Spread of anything. Like let's say, as we had studied in physics, if there is a prism here and if you put a white light this side, so when it comes out, it disperses into several different wavelengths of light, right? So that is dispersion. What does it show? It shows this spread of, okay, whatever. So dispersion means spread of what? Spread of the data. Huge number of data is spread everywhere and there is no sense of that spread out data. So what do we need to do here? We will try to collect all those data. We will try to bring it in organized manner, and after we organize the data, we will try to make sense out of that data, try to analyze the what is the data telling us, what is the interpretation of the data. Okay, so every number here has certain significance and meaning. Okay, so that we will try to understand. So that is under dispersion. So this we already know from class 9, 10th, 11th, 12th we studied, so not that much amount of time we will spend there. Rather we'll be talking about the range, the mean deviation, standard deviation, variance, coefficient of variation, okay, standard error of mean. These are interesting things. Okay, so we'll be starting with the mean. Now what is mean? Mean is nothing but the arithmetic average. Arithmetic means, like, let's suppose, as I am a medical student, so I'll be using medical stuffs. Okay, so let's suppose there is patient and there is hemoglobin. HB is nothing but the hemoglobin. Okay, and this video will be helpful for all the math students also. Okay, so patient, here we have the list of patients and their this value, hemoglobin value. What is hemoglobin? Hemoglobin is present in our red blood cells, that carries oxygen. Okay, so in this data, as you see the data, hemoglobin, the patient number 1 has hemoglobin around 13, 2 has 12, third one has 12, fourth one has 14, fifth one has 13. Okay, so these are the normal data we have got. Now, so what is mean? Mean means, now we already know ki mean is nothing but the average. How do you take the average? You just add all of them and divide by the number of values, whatever the observations is there. The single value is called as single observation. Okay, so just add 13, 12, 12, 14, 13, and total number of observation is 5. So as you add and then divide, you will get something. That number is 12.8. Now if this, you don't see all this screen, whatever it is there, okay, just leave it. Now as I told you, the mean value of this data is 12.8. What do you understand by this? Like, what is the feeling you get? Do you get any kind of feeling? The feel of this number is that, so out of this 5 patient, if I have to take one single number, one representative number. What is one representative number? That means out of all that values, one number, if I have to define, like, let's suppose in a class there are 10 students and all of their weight ranges from 50 to 60. Okay, and you take you take the mean and you get a one, like this one value you will get, let's say 55. Okay, now as I told you, 51 to 60, let's say 51, 52, 53, 54, 55, 60. So mean value will be 55. Now this is one single number. Now let's suppose someone has come and told me, okay, this class has 10 people, can you tell me what is the average weight of that class? So I can tell now, average weight of that class is 55. So this person understood, okay, this class average weight is 55. Okay, now similarly, if I take some other class, that class average weight is, let's say, 70. That class average weight is, let's say, 100 or 200, 100 or 150, whatever. So what can you interpret with this data? What can we interpret is, okay, so this class had a range, not range we'll discuss, but just the mean. So this class mean was 55. That means, now if I talk about the normal range of a particular age group and a particular population, it lies from this much to this much. So 55 is a relatively stable and good amount of weight. Okay, let's suppose some 20 years kid or something. Okay, I'm making it complex. So I have got the value, this class has 55 mean weight, this class has 80 mean weight, and this class has 100 mean weight. So I can just, by common sense, I can say that maybe this class has more amount of fat people, maybe this class has more amount of lean people. So out of the data, I could interpret which class has what kind of people. Some may be fat, some may be thin, some may be normal, right? So this is the interpretation. Okay, so we just had the values. From the values, we did something, that is taken the mean and we interpreted it. Okay, so that's how from the values, from the number, from the mathematics, we are trying to understand something. So that is nothing but the mean, and we know how to do this. So you just add and then divide. Okay, so I have got this value 12.8, that is the mean hemoglobin. Okay, that is the mean hemoglobin of these 5 patients. Okay, this set of patients, their mean hemoglobin is 12.8, which ranges between normal. Okay, it ranges normal, neither less nor too high. Now if I draw a line here, and if I interpret this, so from like 2, 4, 6 and 8, where is the mean number lying here? The mean number is somewhere here. If it is 12 and it is 14, the midway should be 13. So just below 13 is 12.8. So that is the mean. This is the mean value. Okay, so this mean value is representing this set of data, representing. And what is this? I told you this is the central tendency. So this is the central tendency. Central tendency means what? The center of this numbers is 12.8. Okay, so now you can see there are blue dots here that I have marked. You can see here. So here at, let's say 12, no, patient number 2 had 12, patient number 3 had also 12. So 2 people are here, 1 people is on the 14, 1 people is on the 13 here. Okay, 2 people are on the 13. So you can see this is the mean number. This line is the mean. Now the data or the number, the observation, these data, the number of peoples, they are just surrounding. They are not here or anywhere. They are nearby, ranging from 12 to 14. Okay, so they are not spread across. So this data is closer, like it is relatively less spread. But is there any way we can interpret, like is there any other tools that we can use to measure how far the data are from the mean? Yes, there is. We will also talk about that. Okay, so yeah, this was one example. Now let's take another example. So let's suppose I'm taking the salary of certain people. Okay, so salary of one person is 10,000, second is 10, 15, then one has gone 65, the other last one is 15. So you leave all this, whatever is there on the screen, you leave all this. Okay, you just see the data. As you can see data, you understood that there is 10,000, 10,000, 15,000, 65,000 and 15,000. So what you can interpret from this data? If you take the mean of this data, do you think the mean will be suitable in this kind of data? Because if you see the majority of the people, like 1, 2, 3, 4 people, all are somewhere nearby. 10,000, 15,000, not much of a difference. These people lie close by. Okay, but this one has shooted up till 65,000. Okay, so don't you think if I take the mean, you will leave all the formulas and all, just try to understand. If you take the mean, don't you think the value of the mean will be shifted towards the 65,000, towards the heavier value? Okay, so yeah, that's what. So mean, if I take the mean is represented by x bar. Okay, so x bar is, you add all the values, divide by the number of values, you will get 23,000 is the mean. Okay, so this is the 23,000 is the average salary shown by the company, let's say, and you are trying to join that company. So do you think you will get 23,000? Possibility is there. It's not like there is no possibility. Possibility is there. You can get 65,000 also, but that is least possible. The average is more here. See, if you just see, it is funny that none of the people is getting any near to the 23,000. Everyone is getting 10,000, 15,000, not even 20,000. Only one fellow has got 65,000. Okay, so that's how the mean is shifted far away, right? It is not anywhere close to the data or the observations or the number of people. That is why not every time mean will be helpful to interpret the data, because this mean salary that is shown here as 23,000, but it is not so, right? You can see that like most of the people are not even crossing 20,000 of salary. All are 10,000, 15,000, 15,000. So why is this happening? Because of this one single data. Now this is one of the extreme value. What are these extreme values are called? These are called as outliers. And because of this outliers is nothing but, so there are some data which are close by, like okay, 1, 2, 3, 4 something, and this one data that is very far away, like 100, 1000, that is much far away. And let's suppose there are 1000, 2000, 3000, you are taking some data, and then suddenly you just take 1, 2, 3. So this is also an outlier. This is the extreme ends The outlier, if the outliers does not match the group of data, the majority of the data that is there in the group, if it's something extremely high or extremely low, then those values are called as outliers. Okay, so who is the outlier here? The 65,000, this chore, this thief. Because of this thief, this thief is the outlier. Okay, so this, because of this thief, the mean salary has shifted. Now this is good for the company, they are able to show that mean salary is this much, but that's not the actual truth. Okay, maybe these people are weeping in the company. Okay, and this guy is having fun. Okay, so so you understood the point, right? It is just like in physics we have studied. So if there is a lever in between, okay, and there is a plank or something, and you put weights. So if all the weights are centered together, then it will be stable. Okay, the mean will be stable. But if there is an outlier, if a big rock, huge rock, let's say these are all 5 kg, 7 kg, 10 kg, and this is some 100 kg, then there will be a tilt, because this will be shifting like this, right? So the mean will be shifted like this. So that is just a correlation. Okay, so we understood ki every time mean should not be trusted, because if you trust mean, then you will be getting less salary. So mean should not be trusted in all the time. So what do we understand from this? We understood that mean is not, trustable. When it is not trustable, when there is thief. What is thief? The outlier. So if there is any outliers, the extremes of the values, then the mean is not trustable. It is not a good measuring tool for the mean, okay, or the average. So is there anything else that we can do? Yes, there is other two possible tools. That is, one is called as median, the other one called as mode. Okay, now let's suppose I'll take the same example. Okay, salary. So here I just neglect the zeros. Okay, just take 10, 10, 15, 65 and 15. So median, in median what do? You arrange the number in ascending order. So once you arrange the number in the ascending order, like 10, 10, 15, 15 and 65. Okay, so 10, 10, 15, 15 and 65. You have arranged in ascending order. That is important. You arrange the numbers in ascending order, and then you take the middle value. Now it is easy to take the middle value of the odd numbers of data set. Okay, what about the even number? So we'll talk about that. So here, as you can see, 10, 10, 15, 15 and 65 I have put. 65 is the outlier, that is this thief. Now which one is the middle value? The middle value is the 15. So the median is 15. Now does it make sense? Now if I say the median salary of this company is 15,000, okay, now you will understand ki, okay, median salary is 15,000. Now it is more trustable data, right, rather than mean. Mean was showing some 23,000, but median is somewhere around 15, which is at least close by to 10,000, 10,000, 10,000 or whatever. Okay, so the median is not affected by the outlier. Outlier is the extremes of data. You put here 65 or you put here 100, 1,000, 10,000, whatever you put, it doesn't matter, because we are not considering the outer outliers. We are taking the median value. So in this case we can use the median value. Okay, that is called as the median salary in companies and all. Okay, but this was easy because it was odd numbers. So we had 1, 2, 3, 4, 5 numbers. So 5 is odd number, we can easily pick the middle one, 15th one. What if it was even number? So for even number, let's suppose like this, you have one more, you add 20 or 17, whatever. So in case of median numbers, what you do is you take the middle two, you take average of the middle two. Like there is 15 and 17 here, you take average. 15 and 17 is what? 32 divided by 2 is 16. So 16 is the median value here. And if you see, the 16 is closer to 15, it is closer to 17, closer to 20, closer to 10, but it is far away from 65. And anyways, it is not affected here. Either it is here 65 or you put 1 crore, 2 crore, whatever you put. So it doesn't matter there, because we are considering the middle values. So that is the median. Okay. So we understood that in the mean, if there are extreme outliers, that will affect the mean and it will give the false interpretation of the data. So in order to tackle that one, we had this another tool, that is the median, where we are arranging the numbers in a particular order, that is the ascending order, and then we are picking out the middle values. If it is odd, you just take the middle one. If it is even, you add the middle two values and then you take the average of them, and that will give you some data which will be close to the majority of the data. Then what is mode? This is one another way of interpreting the data, where you can understand, okay, which data is more here, which data is majority. Now let's suppose in this value, one people, two people, three, four. So two people are getting 10,000, two people are getting 15,000, and one person is getting 65,000. So if I tell the mode is nothing but the frequency. The more the number of frequency, that is the mode. So which is more here? 10,000 two people, 15,000 two people. So here two modes are there. This is called as bimodal distribution. So you can see mode is nothing but the which one is the more frequent. If some value is repeating bar means repeatedly one value is recurring, then that value will become the mode. Now in this there are two kinds. One is numerical, the other one is non-numerical. If I say about the numerical, then let's suppose we take some random numbers, 70, 80, 80, 75, 75, 100, 90, 75, 73 and 75. So you can see that 80 is repeated twice, 75 is repeated thrice, one time 100, one time 1. Okay, this what is this 1 and 100? 1 is outlier, 100 is outlier, because 1 extreme ends. Okay, so what do you think is the mode? As I said, mode is nothing but the increased number of times whatever is recurring. So 75 is the mode here, because it is recurring 4 times, one more here. Okay, so 4 times, this is the mode. So similarly you can understand ki the number which is most repeated, that will be considered here. Okay, so here also you are not worried about the extreme outliers, because that is not affecting the value here. So this is also one way you can understand. So let's suppose in a company there are 10 people, 9 people are getting 8 let's say 6 people are getting 7,000, 2 people are getting 10,000, one person is getting 1 lakh. So let him get 1 lakh. What is the problem? The company cannot say our mode is 1 lakh, because that is not the majority. Majority is people are getting 7,000 or 8,000, whatever. That gives more sensible interpretation. So that was the numerical part. But this mode is also used in the non-numerical datas. Like let's suppose in a class there are 30 people, and out of the 30 people, how many people like statistics or not? So it is how many people likes or not likes. So it is yes or no. So let's say 20 people does not like statistics and 10 people like statistics. So here the mode is 20. So that is the mode. Okay, the 20 is the highest number of frequency. Highest number of people are saying no. So that becomes the majority. So that is the mode. Another similar example can be if somebody likes some color. Let's suppose out of 30 students, 2 likes blue, 10 likes red, 18 likes pink. Okay, so majority is the pink. So that is the mode. Similarly, you can find it in blood group, like in a population, how many people has O blood group, how many people has A blood group, B. So whatever is the majority, that will be the mode of that population. Okay, so here we understood. What did we understand? That mean is a good tool to estimate the average, but there is some limitation of the mean, because if there are any extreme outliers, like if there are extreme values, then that will deviate the mean. Okay, that will not make so much sense. Then to tackle that, we have median and mode. So median is nothing but you arrange the data in ascending fashion, ascending order, and then you take the middle one. If it is odd, you just take the middle one. If it is even, you take n plus 1 by 2. That is the formula. You take the nth term plus n plus 1th term, and then you take the average by 2, and then you will get some data. That will be the median. And in mode, you just take the frequent one, which is the more frequent, that will be the winner. Okay, so that is the mode. That was the basic about mean, median, mode. If you are still confused about mean, median and mode, let me help you visualizing this. Okay, so if you have not understood anything till now so far about the mean, like what is mean, why are we taking mean, what is the mean, like if you are not visualized anything, if you did not feel anything, so let me help you. So let's suppose this is some random data arranged here. Okay, so this is 1 2 4 let's suppose these are jamun. Okay, so one person has one jamun, second person has two okay, leave jamun, you take balls. Okay, wait, let me make it more interesting. Let's suppose this is you. Okay, this is you, I'm talking to you, this is you, whoever is watching now. Let's suppose this is you, and I'm hoping you are someone of my age. Okay, so we are like friends now. So this is you, and let's suppose this is me. Okay, this is me. So you have one ball, I have two balls, and let's suppose this is one of my friend, Chaitanya. Okay, Chaitanya has four balls, and then let's suppose this is one more person called as Devansh, he has five balls, and then let's suppose one more person, his name is Dev, and he has eight balls. Okay, so just random numbers, random names, don't worry so much. So you have one ball, I have two balls, Chaitanya has four balls, Devansh has five balls, and Dev has big guy eight balls. Okay, now we all of us has this many balls. Now we want to take the mean of all these balls. Mean of all these balls means, now as I told, we are approaching a central point, or we have to represent this data in a single term. So all of us, me, you, me, Chaitanya, Devansh and Dev, we all have overall, let's say you add all the balls. 8 plus 5 is 13, 13 plus 4 is 17, 18, 19, 20. So overall we have 20 balls. Okay, so overall we have 20 balls. Now if I take the mean, what did I tell you? Mean is you add all the values and you divide by the number of people. So how many people are we? 5 people. Now if I divide this, what am I getting? I am getting 4. Okay, so what does it mean? Did this click anything in your brain? So 5 people we are, you, me, Chaitanya, Dev, Devansh, all of us has 20 balls, and I took the mean. We have mean as 4. What does it mean? Now let's suppose 4 means, who has 4 balls here? Chaitanya. Chaitanya has 4 balls, you can see here. So 4, what does it mean? What is the meaning of 4? So when I took the mean we got as 4. What does this 4 mean? This is the central value or the representative value. Now who has 4 balls here? Chaitanya has 4 balls. Now if I have to rearrange the balls here, then how will I rearrange to make this data more visually representable? Let's cut this one and let's give this ball here. So I am giving one ball to you. Okay, keep it. Now next cut this ball and I am giving one more ball to you. I am giving one more ball to you. So now you have 4 balls. I still have 2 balls. I still have to get 2 other balls. So I am taking other 2 balls. Now I also have 4 balls. Okay. Now Dev has lost his 4 balls and Devansh has lost his 1 ball. But every one of us now has 4 balls. So that is nothing but the mean. Mean means you are calculating a value from the data, that this is the average. Now all of us, initially only Chaitanya had 4 balls. Few had more, few had less. Now every one of us has 4 balls. Okay, thanks to Chaitanya. So this is nothing but the visual representation of the mean. Okay, now, so I hope it was at least some meaningful to understand what is mean. Okay, now let's talk about the conclusion. Like, what is the conclusion of the mean, median and mode? So mean, as we have told, see, mean is represented by x bar. Okay, so when is the mean used? Mean is used when there is normal distribution. Normal distribution means 1, 2, 3, 4, 5. Now this is normal distribution. What is the mean? Mean is the 3. That is known. That is, you don't have to calculate for that thing. Okay. Then if there is clustering around the single point. Clustering means if you take like this one number line. Okay, something you will take and then you will get a mean. You put a line there. I will show you a better one. Okay. So here. So as we have calculated, okay, this is the mean salary. So see here, after you after you get the mean, when you plot the individual point of the observations, then you can see that there are few group here, one person is here, so this is the cluster, right? So the mean will make more sense if the mean is surrounded by that cluster. Only then it will make sensible data. If someone is outside, that is the outlier. That means that one data is extreme, and because of that data, because of that one particular value, the mean is shifting towards that side. Okay, this gives me a feeling of gravity. So what is the conclusion? So the mean or the average will be helpful if there is normal distribution and if there is clustering around the single point. The clustering of that individual value should be at that surrounding the mean. Okay. So what are the, like if we are talking about biostatistics, then something will add with whatever the medical terms. So it is preferred for estimating the average hemoglobin values, average height, as average systolic blood pressure, body temperature, and pulse. Why these are preferred? Because this has certain range. Like hemoglobin, if you take, a majority of the population will have 12 to 16 maximum. Okay, you take boys or girls or whatever. So there is like, there you won't find someone's hemoglobin 1,100 or something. You won't find someone's hemoglobin 0 or 1 2. He will be dead. So that's not possible. No, so extreme outliers are not possible in this case. Like hemoglobin, height, you won't find anyone 1 kilometer of height. Okay, so that becomes the extreme. So what are the values which naturally does not have feasible outliers, extreme values? That all those we can take the mean or the average will be much better tool for the average value. Not preferred, mean is not preferred in case of salaries. We have seen there are disputes. Okay, so in that case we can use median or mode. Then let's suppose hospital stay. If you are estimating ki this hospital on an average patients they stay for how long. Let's suppose one patient is staying for 2 days, 3 days, one patient is staying for months together. Okay, so that is the extreme outlier. So there also it is not preferred. Better you take median or mode. You just arrange in an order. Let's suppose someone 10 patients are there. 10 patients, out of 10 patients, you take one patient is staying 3 day, 4 day, one is like 5, 6 day, and one is staying, two are staying like 30 days, 60 days. So the you put it in ascending order and take the middle value. That will make more sense, or even the mode will make more sense here. Survival for the cancer, median is preferred here, because even in this case also there are certain people who die immediately, there are certain people who lives for long time. So at that time also, if you take the mean value, it will give a false interpretation. Okay, this is the value, mean value. Here also median is used. So median is nothing but the mid value when it is used when there is a skewed distribution. Skewed distribution means the data is arranged haphazardly, like there are low values, high values, extreme values. Okay, so it is not in organized fashion, or it is not in it does not comes under normal distribution. There median is much preferred. And if there are outliers means so, and this cannot be used in the categorical data. Categorical data means I told you mode, it can be non-numerical also, like yes and no question, how many like pink flower, red flower, whatever I gave the example. It's like most common blood group. What is the most common blood group? Someone will say O positive, A positive, B positive. Okay, so that thing here. So whoever after the research, whatever frequency you get the more, that will become the mode. Okay, so that thing here, there is no value. No, you are just taking some alphabet like O or A, B. Most common disease. Will you do any numerical data here, like 0.5 dengue, 6.7 malaria, 3.4 random disease? So that is not a numerical data. So this is just the name. So 20 people has malaria, 50 people has dengue. Okay, so that you take. Then most common contraceptives and most common resistant antibiotics. So these are some example where you can use mode. Okay, so that is the categorical data. In categorical data you can use mode. Okay, so we understood about the mean, median and mode. Now what is the time? Time is 49:50 minutes. Okay, now this So that way understood about the mean, median and mode. So the first central tendency, the mean, median and mode, we understood. This part is over. Now still we are remaining with the dispersion, which we have range, mean deviation, standard deviation, variance, coefficient of variation and standard error of mean. Now this has taken this much amount of time, and this will take much more amount of time because this was too simple. This was not so much a problem. This is also, I will not say as simple as this, but this is much more interesting than this because this is where the real game is. Okay, so what I will do is I will break this video here and I will make one more video. I will record one more lecture and there I will discuss the dispersion. So this will be a two-part. So you don't go anywhere, just continue the next video. Okay, you can just tap here or here, whatever. Okay, so I'll just stop it. In this part 2 of the video lecture, we will be trying to understand these concepts. Okay, under the dispersion we have range, mean deviation, standard deviation, variance, coefficient of variation and standard error of mean. Now this we need to focus on here. So here we were trying to understand the central tendency in the first part of the video. Okay, you make sure you have watched that. Okay, you will get some idea about the statistics, what it is done, how the data is interpreted. Okay, what are these numbers and values, why are we taking mean or median or mode. Okay, like what is the feeling of this data and the interpretation of that, and why do we need this in regular day-to-day life. Okay, so I have told something about the central tendency in first video. Okay, it's not like I can cover everything, but whatever I felt, whatever I could make some sense out of that, I have told. So that is the central tendency. Now we are talking about the dispersion. Dispersion is nothing but now we are trying to understand this spread of the data. From the mean value. So already the data was spread, then we have taken the data, we have taken a mean, we got one single value, that is the representative value. Now if we want to know that the individual data what was there, how far is that data from the mean. Okay, so now let's say 1 2 3 4 5 number of sets. I mean one set has 5 number. What is the mean? 1 2 3 4 5. Mean will be 3. That is the if you calculate, you will get 3 only. Now if I say how far is 5 from 3, it is 2 units far. Or how far is 1 from 3, it is 2 units far. So this is a uniform distribution, right? If I say how far is 4 from 3, 1 unit. Similarly with the 2, 1 unit. So because this 1 2 3 4 5 is a uniform distribution, we are easily able to say, okay, this value is this much far from the mean value. Now you take huge number of data, 100 numbers you take. Okay, n value is 100, where the n value means the number of observation is 100. Then, and if the data are too large, and then how do, but the concept is same. You take 1 2 3 4 5, or you take 1 lakh, 2 lakh, 3 lakh, 4 lakh, or whatever the number you take, the concept remains same. You take the mean, from the mean value, that central tendency or the representative value, from that representative value how far is each individual. Okay, now let's again, I have to take examples. There is no other way we can understand statistics until or unless you understand what is the concept behind that. Okay, the intuition, there should be like you should understand the meaning of these values, the numbers. These are if you just go on studying and practicing this, you might get used to practice the formulas, but you won't understand the formulas, or you won't understand this thing, like what's happening here. So better you just understand what's happening, then it will be more sensible. So if I take 5 employees, like 10,000, 20,000, 30,000, 50,000, until 50,000, 10, 20, 30, 40, 50, mean is 30,000. Okay, again, now if you see the average of this company's salary is 30,000. Now one person is getting 10,000, one person is getting 50,000. So someone who is getting 50,000, how far he is from the mean? Okay, he is 20,000 rupees far. Or how far is this 10,000 person from the mean? It is 20,000 far. So he will have to work hard or whatever he has to do, he should do in order to at least come closer to the mean. Okay, so that's how you interpret. But anyways, then we'll try to calculate the mean of all those average farness, that is the standard deviation. Okay, so first let's understand about from the simple we'll go towards little complex. So range, what is range? In physics we studied that if in a projectile motion, if you have to throw a stone, the farthest whatever velocity you can give, you give, that doesn't matter. But with that velocity, whatever is your capacity, if you want to throw a stone to the maximum distance, then how do you calculate? We used to calculate the r is equals to u square sine 2 theta by g. Okay, and the angle we used to take is 45 degree, because 45 degree, if you do sine 2 theta, that is sine 90, sine 90 is 1, so r is equals to u square by g. So that is numerical, that is mathematical. Okay, so everything here is mathematical. So the maximum range or r max is equals to when you take angle as 45 degree. If you take little less angle, okay, let's suppose if I have taken, let's suppose if I would have thrown it in this direction, that is, let's suppose it 30 degree, then if I put here sine 60, sine 60 is root 3 by 2, so u square root 3 by 2, how much is that? Root 3 is 1.7 by 2, so 1.7 by 2 is some whatever the value you get, that is less than 1. So if you are multiplying some number which is less than 1, let's suppose 0.9, 0.8 or 7, then whatever you are getting, the value is that the value will be less than whatever it is, like u square by g. This is here you have into 1. Okay, now next value if I take u square by g, and this value if I take 0.9, so this value will be bigger, this value is lesser, right? So either you take this value, or if you go even higher, let's say you take this 60, so whatever the value it is, only 45 will give you the maximum value, that is the range. So here we are calculating how far the maximum thing is, that is in physics. Similarly here also, okay, let's suppose if I talk in terms of medicine, the normal range of fasting blood sugar is 80 milligram per deciliter to 400 milligram per deciliter. So if I tell this range, what are you able to understand by this? What is the interpretation? The interpretation is that the range is what? One is maximum value, one is the least value. So a person has the normal value, that is the 80 milligram per deciliter fasting, and one person has some dangerous high levels of value, that is 400 milligram per deciliter. Okay, so this is what he like, what is the range? If I minus 400 minus 80 is, I am getting somewhere around 320 milligram per deciliter. So that is the range. You are getting my point? So that is the range. So within that values there can be n number of people. Okay, so this is just the example. Now if we go much deeper, so you can see one diagram here also. Here, why is range important? Because in medicine everywhere there is range. You take hemoglobin, you take normal blood sugar, you take normal BP, okay, whatever it is. So there is a huge number of ranges, normal ranges. So that's why we need to consider from here to here it is green zone, that means that is normal. Something above this will be tending towards the dangerous level, something towards below this tending towards the dangerous level. Okay, so that is why range is important. Now the limitation, what is the limitation of this range? The limitation is that it ignores the values in between. Like as I told, how are we calculate range? We are calculating the range, the highest value minus the lowest value. So in between all the values whatever you have, so let's suppose the lowest value is 1, highest value is 1000, you take the range 999. Between all the values you don't consider. So okay, that's the limitation here. So if I give an example, let's suppose in a class there are 30 students. Out of that 30 students in mathematics exam, maximum students scored 20 out of 100, 99, 90, 95, 100, 90. Okay, so 30 students में करीब let's say 25 students, 26 students have scored between 90 to 100. One or two students scored 7, 8. Okay. Now, if the teacher has to give a range to the principal, okay, in my subject, what is the range? Now, because of this 1, 2 student who has got 7, 6, the teacher has to write the range from 7 till 100. This is the range. So, people have got 100 also, people have got 7 also. Now, the principal won't understand, no, that maximum students have got what, because that is the range is not telling that value. Range is just telling someone has got 7, someone has got 100. Now this can be possible in two ways, like the majority of the population can be towards the 100, or majority of the population can be towards the 7 also. But that's not how, but that we do not know how is that distributed, right? So that is the limitation of the range. Because here 29 people might have got 100, only one people might have got 7. There also you are writing 7 to 100. So because of this one person, you have to make the range from 7 to 100. So principal will get angry, why someone has got 7. But if the range was shorter, let's suppose if it was from 95 to 100, that means you are telling that in the mathematics 95, many people, like out of 30 people, the last mark was 95, the highest mark was 50. Sorry, what I'm telling, 100. So the maximum population is ranging or lying in between 95 and 100. So you can interpret, right? Okay, this class is better. This class is much better. This is the toppers class or whatever. So that is how we understand the range. But the limitation is that it does not tell how the number or the observations are distributed, either towards the good values or towards the bad values or towards spread across entirely or something. Okay, that it does not tell. So this ignores the values in between. So class A has 51, let's suppose I have given example 50, 51, 52, 53, and one has got 100. So the range is same here. Range is 50 only. 100 minus 50 is 50. Now you plot it here. You plot a number line and you see majority of the people, like 50, one person has got 50, one person has got 51, one person has got 52, one person has got 53, one fellow has got 100. So the range is from 50 to 100, but majority of the population is here now. Okay, majority of the population is around the 50, around the passing marks. And let's suppose in class B it is arranged in 50, 60, 70, 80, 100. Here is also same range, 100 and 50. So if you minus, again you are getting the range as 50 only. But here the population is uniformly distributed. Someone has got 50, someone has got 60, 70, 80. So it is uniformly distributed. But here it is not uniformly distributed. That we can see, like after I have drawn this visual, you are able to understand it is uniformly distributed or not uniformly distributed. With the values given here, we can understand that. But if the value is not given, if only the range is given, then you won't be understanding what population is distributed. So that is one range limitation. Okay. So if the range is more, the diversity also will be more. More range. If I tell 1 to 100, 100 is the range. So 1 to 100 means you can take any value in between. But if I say 99 to 100, there is no value there, right? Only one single value can be there. But 1 to 100, 100 values can be there. So that is the range. Range. Measure of the spread is not clear here. That is the limitation. No, that we will understand in other mathematical tools of statistics. Now next I will tell you mean deviation, standard deviation. There we will be trying to understand and visualize how the data is spread from where? Spread from the mean value. Okay, so there is this mean value, and from there how it is spread. That we will visualize. Okay, until or unless we don't visualize these things, this won't be understood. So let's suppose class A, class B and class C. Again I am talking about range here only. I'm trying to give you, like, from all the perspective, if you see how can you understand the concepts. So class A, class B and class C. Class A, let's suppose the range is from 35 to 90, 55. Class B 90 to 95, 5. Class C 35 to 45. So this is the natural class, like this is how usually it is. So there are people who gets 35, there are people who gets 90. Now let's suppose in this class 10 people are there, in this class also 10 people, so all of this class is 10 people. So if you can see the number line, here is 35, here is 90, one person has got 90, one person has got 35, and this is how it is distributed. 3 people are here, 1 people is here, 1 person is here, few people are here. So this is how it is distributed. Okay, now the range is more here, no, that is why the line is also more here. It is like the scalar quantity. Okay, the line is also more here, the distance of that line is also more here. In class B, from 90 to 95 is the range, so this is a relatively good class. So here the range is small, the range is only 5, inside that the values are densely populated. Okay, so this is a, you can interpret that this is a good class. These people are scoring from 90 to 95 and the range is 5. Okay, then class C, if you see 35 to 40, these people are scoring. Again the range is small, this one range and this one range is also small, but you can interpret in many ways, like few people is populated here, few people can be populated here, or it can be evenly distributed. That you will not know until or unless the value is given, until or unless you visualize the data. Okay, just by the range you won't be able to understand. So that is the limitation. So that was about the range. More the range, more is the diversity. So we understood about the range also. Next what we have the mean deviation. Now we will try to understand real stuffs. Okay, now real statistics will begin slowly here. So we'll go slow a little bit. So mean deviation, first of all, mean means what and deviation means what. So mean is nothing but we are taking the number of values of the data and we are dividing the total number of observation by that. Okay, so if you just see this number, I am taking very simple values 1, 2, 3, 4, 5. If you don't have to calculate for all this, you just know that mean is on 3 because it is equally distributed. So after you take the mean is coming on the 3. So x bar is nothing but the mean, and you already know this. Now let's suppose this person has 1 apple, this person has 2 apple, this person has 3 apple, 4 apple and 5 apple. So 5 people are there and all of them have this many apples. So total if I do, then you add 5 plus 4 is 9, 9, 10, 11, 12 and 15. Total we have 15 apple. People are how many? 5 people. Total apples are 15. You divide 15 by 5, then you will get 3. So now if I have to equally distribute the apples, then how will I distribute? So here this person needs 2 more apples. So I can, this person has 3 apples, he is mean, he is the, like he is this person is satisfied, he has 3 apples. Here this person has 4 apples, this person has 5 apples. Now if you want to redistribute the data, then you will add 2 more apples here, you will add 1 more apple here, then everywhere from where you will get 2 apple, from here you can take 1 apple, from here you can take 2 apple, one you give here, one you give here. So all of them now has 3 apples. That is the mean, one representative value. Now all of us has 3 apples, that is the average. Okay, now what about the deviation? What do we mean by mean deviation? Mean deviation means, now what I will do is, whatever the value I had got in the mean, that is the 3, if I minus that 3 from 1, okay, from 1 in the sense, now you remove these apples, you just look at the number line in a mathematical, you just think like a mathematician now. So I had this is the value number 3. If I minus this 3 from 1, how much am I getting? 2. That means from the 3 and 1, like how far is the 1 from the 3? 1 is 2 units far. How far is 2 from 3? 1 unit far. How far is 4? 1 unit far. How far is 5? 1 unit far. Okay, now I have got the values. This is 1 unit far, this is 2 unit far, 1 unit far, this is 0 unit because that is lying on the same line, this is 1 unit far, this is 2 unit far. So if I add all of them, here I will 2, 1, 1, 2. So 2, 2, 4, 5, 6. I am getting 6. Now 6 divided by 5 is equals to 1.2. This is the mean deviation. Mean deviation, like first we calculated the deviation. Deviation means what? How far that value, a single or individual value from the mean. So we understood that this value is this much far. Then I have taken that value and I have added. I have added with the other value which was this much far. Then the other value was this much far. So all this value, this deviation all the deviation, I have added all the deviation. Here also, in the earlier also I was adding all the numbers and dividing by the 5, the number of people, that I was getting the mean. Here also I will add all these deviations from the central value, from the mean value, and then I will again divide by the number of people. So that is the mean deviation. Here we are taking the mean of the deviation. You are getting my point? So mean deviation is 1.2. Now what is the sense of this 1.2 now? Like, what is this 1.2? Is this something that you can eat, or is this something that you can kiss, or is this whatever? What is this 1.2 now? On an average, if I consider all these values from the mean, this is 1.2 units for, or 1.2 units for, on an average. I am telling here again, average. Okay, so that is the interpretation of the mean here. Okay, on an average, how far is individual data? Now if this number 5, he had 10 apple, 20 apple, 30 apple, then there would have been different datas, different values. You can just play with the numbers. You sit and you try to play with, arrange all these numbers, and then you will understand. What is MAD? MAD is nothing but the mean actual deviation, that is 6 by 5 is 1.2. So on an average, whatever you take, either you take 4 or 5. Now I cannot say 5 is this much far. Now if there are 100 values, will you say that 99th value is this much far? For all that individual, you cannot say that. So on an average, this much far it is, you can say. That is one single value. Okay, so that is 1.2. Let's take one more example here. Let's say 150, 90, 180, 300, some random numbers I have taken. Then I have added all of the values and then divided by 5. That is the mean. That is nothing but the mean. That is 124.2 is the mean. So where it is, 90 is here. So somewhere here will be 124.2. That is the mean. Now how will I take the mean deviation? Now for the mean deviation, I had done what? I had minused. Like I have taken the difference between 124.2 from the first value, from the second value, from the third value, fourth and fifth value. So 1 minus 124 will give me a negative value, like minus 123. But if I put negative value here, put negative, like there will be few values which will be negative, few values which will be positive. And if you add both positive and negative value, it will become 0. So that will not give anything. That will be like, in physics we use vectors. So if you go in this direction and if you equally go in this direction, then you are going nowhere. You are at the center point. So but if the distance is not like that, distance is a scalar quantity. So no matter how far, how circle or whatever curves you have taken, wherever you go, it is always increasing. Okay, so something like that, this should be considered as distance. Okay, so if you go this way or this way, it measures, it counts. So 1 minus 124, it will become minus 123, but we can take the modulus. Modulus is, it becomes positive. Okay, that is the magic of modulus. So you put whatever inside the modulus, it becomes positive. So 123, then you will minus the 50 minus 124, you will get 74. 90 minus 124, you will get 34. Then similarly 56 and 176, and then you take the mean of all this value. If you take the mean of all this value, you will get 92.6. So on an average, this is the mean value. If I want to know the individual datas, how far it is, on an average it is 92.6 meters or units far. Okay, on an average the distance or spread of the individual data is this far. So that we get some idea about the spreadness, okay, how far is single or individual data from my mean value. But this is not so much accurate. So this was also one of the tool where we understood that individual data is how far. But better than this data, we have one more thing called as standard deviation. Okay, so standard deviation, this is much more refined or fine or accurate tool that will give accurate values ki how far or on an average how far it is. So let's understand about that. Now let's suppose we'll understand both again, mean absolute deviation and standard deviation together. So let's suppose there was a microbiology paper and pathology paper. So let's suppose that I taken 6 people here. So in microbiology paper, Now I am comparing here two things now, right? So microbiology and pathology. So in microbiology, one person has got 61, 64, 69, 72, 78 and 79. Okay, now these are the values. You just see what I am showing with the cursor. Don't worry about these things, this part. So you add all of those values and you divide by 6, you will get average or the mean value is 70.5. So you make a number line. This is the your average from 60 to 80, midway somewhere it is 70 point, okay, 70 and 70.5. And if you put individual data, if you put individual data here, see, this will be spread like this, something like this. So 61 is here, 64 is here, 69 is here, 72 is here, 78 and 79 is here. This is how you are getting the individual values of that population, of that data set. Now mean deviation, what did I say about the mean deviation? Mean deviation is that you go like how far is individual data from the mean value. So mean value is 70.5, you now minus all these things, so you will get minus 9.5. if you minus from this value, you get minus 9.5, but you ignore the negative values. Okay, you take the modulus, so you will get 9.5 positive value, 6.5, 1.5, 1.5, 7.5, 3.5. On an average, if you sum this, you will get 35, and you take the mean deviation divided by again 6 is 5.8. so this is the mean deviation. That means from this central value, from this 70.5, on an average the mean deviation is 5.8. okay, so these people, for microbiology the mean deviation is 5.8. this you understood. So here the value is 5.8. that means from the central value is 70.5. if you go like 5 units above and 5 units below, the spread is more among that, maybe one or two values away from 75 or away from 65, this side, behind side. Okay, but the majority of the cluster is around 70 ke aju baju, right? 5, that is 5, mean deviation is 5. Similarly, if you take pathology paper and if you add all of this together, and then you are getting here mean deviation as 22. So you first you take the mean and then you minus and then you take the mean deviation, you are getting 22. Now 22 mean deviation means here the mean deviation is just 5.8. that means not so much of distance or not so much of spread you can feel, but here 22 means it is spread like 20 marks from here to there. So if see here, the mean for this value is also 70.5, the mean for this value is also 70.5. so the mean is same here, but the mean deviation from 7, some person has got how much, 97 also. See, some person has got 97, so here is 100, here is 97. Some person has got 30, so from 30 one person is so behind and the one person has got 97. So it's like it is covering an entire range, right, entire length of that number line. That is why the mean deviation here, what is saying, that if the mean deviation is more, the spread is more. It is not properly, it is not so much reliable. The word I should be using is reliable. Okay, so that is what we are trying to understand from the mean deviation, but better approach is to take the standard deviation. I will show you now. So here the mean was same, no, the mean was 70.5, here also mean was 70.5, but the mean deviation here is less. That means it is more reliable. The consistency of the performance of these students is good. It is not so much less, so much high. Okay, but the consistency is here of the students here is you cannot say a constant predictable value. Okay, this much it can be there, because mean deviation is more. Someone is scoring 97, someone is scoring 30. You cannot say okay, next time also they will be performing like this. Maybe next time all of them are performing bad, coming towards the 30, or maybe next time everyone is performing good, going towards the 100. So that is the mean deviation. More the amount, more the number of the mean deviation, more is the spread, less is the reliable of that data. You are getting my point? Now what about standard deviation? Why is it much more refined version? Because now let's suppose I'm giving you one more scenario here. If you see, Microbiology has some 6 people, they have got this marks. Pathology, few people have got this marks. So mean I am getting as 70. Here mean I am getting as around 71. Almost same, okay. But here if I calculate the mean deviation, how will you calculate? Again, you first you take the mean and then you subtract. Okay, after subtracting you will get mean. After subtracting and dividing by the number of observations, you will get mean deviation as 3.33. So here you got the mean deviation 3.33. Here also you do the same and then you see, acha, mean deviation here is also 3.33. Now if you start looking at the values, here some person has got 75, 72, 68, 65, 67, 73. So you can understand all the people, all the 6 people, they have got values nearby. It is not like someone has got 20 or someone has got 100. Okay, every number is nearby. But here if you see, some person has got 83, some person has got 63, and majority of the people has got 70. So it is little bit spread across, no? Because 73 and then 83, it is ranging from 63 to 83. So here there is little bit of spread that you can just tell by looking also. But more accurately, if you want to tell, then you have to calculate the mean and then mean deviation. But here with the mean deviation also, if you take the mean deviation, if you calculate mean deviation, you are getting 3.33 and 3.33. So even here you will not be able to understand which one is more reliable, the data. Matlab, the mean value what is there, from there how the data is arranged or how far spread of the data you won't be understanding with mean deviation here, because both have the same mean deviation 3.33, 3.33. But here you could have understood, because here mean deviation was 5.8, here mean deviation was 22. So you understand 5.8 is less than 22. So this will be more organized, this will be less organized, this will be more spread out, right? But here you won't be able to understand because mean deviation is same both the cases. Then how will we understand? Now here we will use the standard deviation. Standard deviation is much fine, accurate way. Now how do you do that standard deviation? You just, whatever the value you got in taking the deviation. Deviation means what? You minus, you take the difference from the mean value and the individual observation. That means you see how far one individual observation is. If the mean is 70 and some person has got 75, so how far he is from the 70, from the mean deviation, so from the mean, so he is 5 units far. So you are calculating the same 5, 2, 2, 5, 3. This was done when I was calculating the mean deviation. Now now what extra thing you do is you just square those numbers. You take the square of 5, square of 2, square of 2, square of 5, square of this and this, and then you get some value that is 25, 4, 4, 25, 9, 3, and then you add all of this. After you add all of this, you are getting 76. Now again you are taking the mean of all these squares, that is again 76 by 6, and then you are getting some value that is 12.66. Now as you have squared all this value, you just take the under root of that average, then you will get 3.55. So this 3.55 is a value that is not making sense now. Why? Because this is just individual data set. This will not make sense. This will make sense when I compare this with one another data. Like this was for the microbiology. Now for the pathology, I had the mean as 71 and mean deviation as 3.33, like this, 3.33. So mean deviation here also 3.33, but I take the squares of all these values, like 12 square, if you minus and you will get 12 square is 144, 1 square is 1, 8 square is 64, and then I will add all of them, take the average is 35.33, and then I take the square root, and after I take the square root I am getting 5.94. Now you see this value, now you see 3.55 and now you see 5.94. Which value is more? 5.94 value is more than 3.55. That means this value is more spread. Maybe one or other value is somewhere far. He is sitting somewhere far. Okay. So, but the mean deviation, what was there? The mean deviation was same. But with that mean deviation, you were not able to understand where the values are. Okay. So, you see here the number line. If you see here. So from 60 to 80, 60 to 90 it was ranging. If I talk about this values, so from 60 to 80, like last was 65, the maximum was maximum is 75. So you take 60 to 80 range. Here also the least was 63 and the highest was 83. So you take 60 to 90 range. Now in the number line, you are seeing the mean is a 70 and here mean is around 71, somewhere here. So 60 to 70, then 80 and 90. So you take here somewhere it is 70. Okay, so this is the mean. Here also this blue line is the mean. Okay, now if I see the individual data where it is, so someone is around 65, that is here somewhere, someone is 67, someone is 68, someone is more than 70, 73, 72 and 75. So this is how it is arranged. But if you see here, I think 4 people, 1, 2, 4 people have got 70 here, right? So 4 population, 4 people is towards the central value. He is near the central mean value. But one person is far away. See, one person has got 83 and one person has got 63. So one person is far value. So by just taking the mean deviation, you were not able to tell by looking at the value where these values are. But when you do the standard deviation, you got this value. One is 5.94, the other one is 3.55. So by this comparing this value, you understood, okay, 5.94, that means there must be 1 or 2 values which is much farther, that I am not able to get by the mean deviation. But from the standard deviation, I am able to get that feeling ki, okay, this value is much far, or somewhere 1 or 2 values will be spread somewhere. Okay, so that is why standard deviation is called standard, because it is standard. It is used everywhere for the calculation of the deviation from the mean value, to see how reliable the data is or how spread. If the data is more spread, that is not reliable. That is like consistency of students in a class. Performance consistency. If everyone is consistently performing 90, 95, 90, 95, 100, 90, 95, 100, that is more reliable. The spread of data is less here. But if someone is scoring 60, 30, 40, someone is scoring 80, there is not so much of consistency here. Someone is getting less, someone is getting more. Similarly, if you take in cricket also, let's suppose Virat is scoring consistently good. Someone is, but his range is small. Like if Virat is scoring 100, 120, 100, 120, 110, 80, 90, 100. So these are all close values. The consistency is good. But some other player, if he is scoring, let's suppose he is scoring good also sometimes, like 200 if he is scoring, and he is scoring the least, he is getting 1 or 2 or 50, 60, and then he is getting out. So the range is good. But consistency is less. So all this consistency, all these things are required to calculate, to know. Like, why is this important to know? Whether which cricket player you want to bet on, or you want to send, take in the team to win the game, or how will you approach if the students are not performing well. So all these things comes under all these values, whatever you are seeing here, 3.33, 8.44. If you just look at this as a numerical approach, you will not feel anything. There's just data. You're just in the exam you are getting a question, you know how to do it, you are just doing it, and you are not understanding like why are you doing this, what is the application of this, what is the feeling of individual number here, what is 3, what is this 3.55, what is 5.94. Okay, like if I compare this with the physics, in physics F is equals to ma, that is force. If you drop one ball from here this height to down, so it will go and smash the ground. So if you take force is equals to some amount of kg, 5 kg, and acceleration of gravity is 9.8 or 10, so 50 newtons. So you can understand that impact. Okay, this force means newtons, something is there. But in statistics you are not able to feel such thing. No, there is no units here as such. Like what is this data telling you? You are not able to feel that thing. But you feel that value when you multiply mass into acceleration. You feel that impact. Yes, it is a force, and this gives an impact. So there you will understand better. But in statistics it doesn't give that kind of feel until. So this is all comparison. You have to compare data, too much numbers and numericals, arrange, calculate, and then gives some sense of feeling here. Okay, so we understood about the mean deviation. What is time? It is 47. So I think I will have to make one more part for this video. So we understood the range, mean deviation and standard deviation. Next, in part 3 of the video, we will be trying to understand the variance, coefficient of variation and standard error of mean. Okay, so this is becoming third 3-part. Okay, are you able to understand something? If you are not able to understand anything, you can just comment down below and I will try to particularly take that topic and I will go in detail of that topic only to make sure that you feel what is going on here. Okay, so in next lecture, in next video, next third part, I will be talking about the what I'll be talking about standard deviation. I have told you, right? And this, see, this is the just the formulas. Okay, what is standard deviation? All this, like standard deviation is designated as sigma, and you take square root. What did I do here? I took the square and then at the end I took the square root. So we just do the square root of sigma x minus x average. What is x average? X average is the mean of the sample. If I take the population, then you take it as nu, but if you're taking a sample, it is denoted as x bar. You do this square and then you divide by the number of observations. Then you take the whole under square, under root, you get this sigma. That is nothing but the standard deviation. That is the formula. Don't worry so much about this. You just know how to do it and you get the feeling. Formula you will anyways remember. If you elaborate the formula, this is how it looks. Okay, so sigma is equals to under root of square, all these things. What is sigma? Sigma is nothing but if you add individual all the things. Okay, that is the sigma. So in next lecture we will be trying to understand what is variance, what is coefficient of variability. Okay, then we will be trying to understand what is there, Bessels correction. Okay, then we will also try to understand the confidence interval. Okay, what is Z score, what is T score, how that thing is there. Okay, then standard error of mean we will try to understand, standard error of mean. Okay, so yeah, there is too much to discuss and this will be more fun and interesting. Once you understand, once you get that feeling of all these numbers, if you start playing with these numbers, then you will understand, okay, now this is interesting. So I will stop it here. Variance, coefficient of variation and standard error of mean. So we had already talked about the range, mean deviation, standard deviation. We understood in the last video also, you can see that. Variance, coefficient of variation and standard error of mean. Now standard deviation, we understood that standard deviation is nothing but the sigma. Sigma is what? Sigma is you are taking the mean deviation. Mean deviation is what? Mean deviation is how far one individual data from the mean. That difference you have taken, you squared and then you added all the values and then you taken under root. That is the standard deviation. Now that means in mathematically, if you take the square root this side, you will get sigma square. That sigma square is nothing but the variance. Okay, that is called the variance. And then we will talk about the CB. CB is nothing but the coefficient of variation and the standard of variance. Now let's come here. We'll talk about Bessels corrections also. So as you can see here, this is the formula for what? This is the formula for the sigma. Sigma means what? Sigma means you have taken the summation of all the. Now sigma means what? Sigma means you have taken summation of all that values, difference from the mean value squared and then under root of that is giving you mean deviation. If you take the square this side, the square root this side, you will get sigma square, and this thing is called as variance. Now what is coefficient of variability? Now what does this mean? Coefficient of coefficient of variability. Coefficient of variability means it is a relative measure. Relative measure means what? We require here two data sets. With one data set you won't be able to make sense of coefficient of variability. It does not say anything. Until unless you have two data sets, there only it gives some insights to what's happening. So it is a relative measure is required for what? Required for comparing two data. Now this data has its own standard deviation, its own mean. This data too will have its own standard deviation and its own mean. Now we need to compare this. Okay, so coefficient of variability, the formula is standard deviation divided by mean. Standard deviation means what? It is a measure of dispersion. Mean means it is a measure of central tendency. So two different things we are taking the ratio and then we are comparing this. So formula is sigma by mean times 100. That is the formula. Now let's take example. Let's suppose this is a company A and company B. The mean return, okay, now this is, let's suppose you want to invest in this company. Now if you want to invest, you also want good amount of returns. So if you, now how will you choose the company? Okay, the mean return of company A is 8 and the mean return for company B is 16. So just by the mean you will tend to think, okay, B has good amount of return, then I will choose B. Now they have given the standard deviation. Standard deviation, he is telling the company A standard deviation is 6 and company B standard deviation is 10. Now what do you know about standard deviation? As I said, standard deviation measures how far the individual data is from the mean. That means what is the dispersion, the spread of the data. If it is more, standard deviation is more, then the reliability is less, the consistency is less. So maybe the company B is giving good return, but the consistency is not good. Consistency is the reliability is not good because the standard deviation is more. Similarly, company A, whose mean return is less, but the performance consistency is good here compared to B. So now you are confused what to do, what not to do. So here you will be using this formula, that is coefficient of variability, where you will be taking the ratio of sigma of this company, sigma and mean, and this company sigma and mean. Okay, after you calculate, so mean return means what? Mean return means the x bar value and standard deviation is 6. So you do 6 by 8. So into 100 you will get 75%, 63%. Now if the coefficient of variability is less, let's say if I, where is my annotate ink, hold on. So CV is equals to sigma divided by x. Now if sigma is more, sigma means what? Standard deviation is more, CV will be more. If the value of standard deviation is more, that means reliability is also less. Similarly, CV, if the value, numerical value of the CV is more, then again the reliability is less. So here you will try to find out which one is less, which the numerical data is less. So if the numerical data is less, that means it is a good one. The company B is more reliable in this case. So this is how we compare. Now if I was not comparing the data from the two companies, if I just take one company, if I got mean return is 8, standard deviation is 6, coefficient of variability is 0.75. What are you interpreting here? Nothing. What will you do with the 0.75 variability with that one data? Until or unless you are not comparing with some other company's variability with similar means and standard deviation, there is no application or interpretation of this data. So that's how. Also you can take, let's two cricketers. One cricketer's mean average score is this one, other's average score is this one, but once his standard deviation is 31, his standard deviation is 40. So here his mean is good, but standard deviation is not so much good. But here mean is not so much good, standard deviation is good. Now again you will use the same formula, sigma by x bar, sigma by x bar, you will get the sum value. So just by looking the value, here is 0.96, here is 0.94. This value is better because it is 0.96, even in the decimal it is better, right? So you will choose this person to bat for the next match. Similarly, if I talk like I had to make this video for biostatistics, so I am just trying to add here and there some whatever medical relevant stuffs. Like if you take young adults mean BP, it is 120, standard deviation is 10. So older adults mean BP is somewhere around 135 and standard deviation is 8. Now if you want to compare these two data, which is more consistent or reliable, then how will you do? So you will take sigma by x bar is into 100, 10 by 120, 10 by 120, this is you are getting 8.33, and here you are getting 14.81. So if the value is more, there is more variation. That means in the older adults, maybe someone has more than 150, someone has 80. Okay, we don't know that. So that not every time in the question you will get entire data or entire data you will require. If you just get these values, you can just calculate like this. Okay, so that was the coefficient of variability, where we are trying to compare two institutions or two separate things. Okay, two separate data sets, that will be more better to say. Again, I have put some few more examples here because this is what we need to learn here. All this mean, median, mode, we all know all this already. So here also you take, let's this I wanted to tell you. So let's suppose here value of A is 1, 2 and 3. Simple. Value of B is 101, 102 and 103. Now by looking at this data, what do you think which has more fluctuations? Do you think A has more fluctuation or B has more fluctuation? A is 1, 2, 3. B is 101, 102, 103. Without looking at screen, if you can tell, like if you, is there any way, can you feel, what can you feel with this data? So if we see here, I am getting mean as 2, here I am getting mean as 102. Standard deviation if you calculate you will get 1, standard deviation if you calculate you will get 1. Okay, so CV1 if I do 1 by 2, mean is 2 is 0.5, CV 1 by 102 0.0098. Now this value is bigger or this value is bigger? This value is bigger. More the value is bigger, that means more the fluctuations. Now did you understand anything? What fluctuations am I talking about here? What fluctuation am I talking about here is, see here. So the value of A is 1, 2, 3. I got CV as 0.5 and the value here of B was 101, 102, 103, right? Fluctuation is more in this and less in this. That by looking at this numerical data I am able to say, but if you just look at the data you will realize this is 1, this is the least value, this is the 3 highest value, okay, in this data set, and it is uniformly distributed. So if I say the variability means fluctuation, or the fluctuation, how much fluctuated. So you can say that once 3 tak gaya hai, that means 3 times, it is 3 times more. But is this same with these values? Do you think 101, 102 and 103 it is increased 3 times like this? The data set hai, how it is increased 3 times, it is 3 times, 3 guna. So 3 times. Do you think it is 3 times increased? If I tell it is 3 times increased, that means I should be getting 303. This is 3 times increased. Then how much is this increase? This is just a fraction of increase, right? 101 से लेके 102 and 102 से लेके 103, just a fraction of increase. So that is that. The fluctuation is this here. The fluctuation in A is 3 times. The fluctuation is more, but here the fluctuation is very minimal. That is what this value is telling us, that the 0.5 and 0.0098, if I compare two data, compared to 0.5, this is very less. 0.0098 is very less. So the fluctuation is very less here. You got my point? So what is the application of this? This application can be like, if you want to compare values of currencies between two countries, like fluctuations here. I have given the example. If you compare this is different example. Let's say if you compare the India's currency value, how it is changing regularly, with the US dollars currency value, how it is changing regularly. Okay, so all these values can be calculated. If you know the mean and standard deviation, you can check the fluctuations between the datas. Okay. Last example, let's suppose, simple again. Person A, he is earning 3000 and his fluctuation or the mean deviation, standard deviation is 500. Okay, and this guy's salary is 30,000 and his standard deviation is 1000. So can you say who's more fluctuating? 3500 is standard deviation, he is getting on, and sometimes he gets 500, sometimes he don't, like that. who is more fluctuating here. So if you just calculate, if you cannot say like this, if you just calculate 500 means what, sigma by the principal, this amount x bar mean, then you will get 16.7. if you do same division here, you are getting 3.3. 3.3 is less, that means it is more stable. The fluctuation in this persons is less, because 30,000, where is 30,000 and where is 1000? It is not so much of fluctuation there, but 3000 ke liye 500 is a good amount of fluctuation. Okay, big deal. If this person is not getting 500 someday, he will be in trouble. But this guy who is earning 30,000, if he does not get 1000, it is not much of a problem to him. Okay, so that's how you understand the fluctuations. The coefficient of variability, that is that thing. Now, after the coefficient of variability, there is something called as Bessels correction. We need to understand what is Bessels correction and how, why it is used. So see here. So what is Bessels correction? In Bessels correction, what do we do is, as you can see, for the population, now you need to understand this. When I say mean, for mean I represent as x bar, that is for a sample. But if I take the entire population, then the mean becomes the new. Now the population is different, the sample is different. Sample is coming from where? Sample is coming from the population. So population is the big man, big person. Population is the accurate, like that takes lot of time and energy to calculate for the entire population. Let's say 100 people, 1000 people. But if you're taking some small, relatively small amount of group of people or something for this estimation, so here you are estimating something, right? Here you are not exactly matching the accurate value with the population, but here rather you are trying to get some population, calculate some data from there, and then you are trying to estimate with the actual population's mean and standard deviation. So for that thing, here we use the sample. So sample size is always less than the main population, the majority of the major population. So when you're taking samples from random here and there, let's suppose, so this is the distribution curve. So this is the entire population, the mean is here. So let's suppose you are taking values from somewhere here to here. If you are taking any values, it can be anything, you take height, weight, whatever. So let's suppose you are taking some values from here to here. So if you calculate the mean is anyway shifted this side, left side. That means it is already biased. The mean is only already biased towards left side. If you are taking values ranging from here to here or something, then the mean is already shifted from the actual mean, that is this side, that is also already biased. Okay, so now after you calculate the sample's standard deviation, so already the mean is biased, the mean is towards shifted from either this side or that side, then the standard deviation will also they say it has underestimates. So the standard deviation underestimates, like the numerical value will be lesser than the actual population. So for that purpose there is a correction. Now how is this correction done? If you mathematically try to approach, okay, then I don't know if you understand or not. So let's suppose there is, what is variance? Variance is the square of the standard deviation. Okay, square of the standard deviation. So if I take the square, this side will becomes under root, so that becomes the standard deviation. But if you take the square root this side, that will become the square, so that is called the true variance. Let's take the true variance as the population variance. So that means so as I told you, so what is mu is the population mean, and what is x bar is the mean of that sample that I have taken, that is already biased. There is always an underestimation, so we need some push towards the actual mean, the population mean, because the samples mean will be always little less. Okay, maybe rare instances where it can be more, but most of the time it is less. So mathematically, now if you want to understand this mathematically how it is done, so you take any number where if you put the values, the number should be less than 1. The number should be less than 1. So what are the values that you can take? Now let's suppose if I take x by x, x by x is always 1, so that is not less than 1 or more than 1. Now if I do x plus 1 by x, if I put x as 2, then 3 by 2 is 1.5, it is more than 1. We do not require that. We require something which is less than 1. Okay, so why do we need that? I'll tell you. So let's suppose x minus 1 by x if I do. Now if I put any value, like let's suppose 2 minus 1 by 2 is 1.5. 0.5 is less than 1. Yes, it is less than 1. So the sample variance equals to the same formula, sigma x minus x mean. Why x bar here? X bar, not mean. X bar means for the sample. So for this is the sample, right? So for the sample is x bar square by number of observations. Now what are we doing is we are multiplying this n minus 1 by n. Why? Because this is giving me a less value than 1, little bit less value than 1. If I overall multiply this with that value, it will give me more. For that reason we are multiplying this now. So sigma of the sample, the variance of the sample, is equals to n minus 1 by n times this whole thing. Okay, this whole thing is nothing but the population, the true variance. True variance is nothing but the population. So this is how we get this formula, and if you just rearrange the formula, so the true variance will be n by n minus 1 of the sample's variance. So this is the derivation, kind of like how are we getting mathematically, because it does not feel like, it feels empty when there is an equation, and if you don't know from where this equation has come, what is the logic behind that equation, then it feels little empty. And if you are feeling empty, then that means somewhere something is missing. So in order to fill that gap, we have understood why this variance has come and what is happening here. Okay, then so for the true variance, you can just calculate the sample variance and then you multiply n by n minus 1. Okay, done. So this is how it is coming. Okay, so here I think this I have done the rough work, same thing. But you can again ask, why only n by n minus 1, why not n minus 2, or why not n minus pi? So if you again, like I have done this, you can also do. If you try to put different values in the place of n minus 1 as n minus 2, n minus pi, n minus whatever you put, then you will overestimate the value. Okay, that will increase the standard deviation value. You can check that out, you can play with the numbers. Okay, we can do the rough work now. That is why when we are trying to estimate the samples mean, the standard deviation, okay, we will use this for the sample standard deviation. If I am using for the population, we will use n, that will give me population's mean. But if I am using for a sample, we need a little push towards the mean. That's why we are reducing the n minus 1. This you can also understand by there is something called as degree of freedom. Okay, degree of freedom means what? Degree of freedom means let me tell you. So we are calculating mean. Let's suppose I am taking x1 plus x2 plus x3 divided by 3, because there are 3 observations and this is giving me x bar. Okay, you got my point. So this is the equation. Now what is degree of freedom? Now let's suppose this value is given already. Let's suppose the mean is, take whatever, 8, random number. Okay, now this value is given, this value is already there 3, because there are 3 variables. Now degree of freedom, what is degree of freedom? Degree of freedom means out of x1, x2, x3, any 2 values you can take randomly, that is of your choice. You can take any 2 values. Now let's suppose I am taking randomly 1 plus 7. Okay, now what about this third number? Can you choose third number? No, you cannot choose third number. The third number is fixed. The third number is fixed here, because if you take any number here, that will not satisfy this 8 mean number, right? So this number is fixed. So what is the degree of freedom? Degree of freedom is 2. That means degree of freedom is n minus 1. What is n? N is number of observation. N is 3. But here the degree of freedom is 2, because only 2 number you can take of your wish, but the third number you cannot take of your wish. Why? Because the third number is fixed. How do we know if it is fixed or not? So 3 8s are 24. 24 minus 8. So x3 is how much? 16. Right? So x3 is fixed here. Until or unless you don't put x3 as 16, you are not getting 8 as mean. So 16 plus 1 is what? 17. 17 plus 7 is 24. 24 divided by 3 is 8. You are getting mean as 8. So here the degree of freedom is 2 for you, because you are able to independently choose whatever number you can with those two values. But the third value is fixed. If you are taking any number, that is fixed. Okay. So that is the degree of freedom. That's why here n minus 1 is considered, because the x bar, that is the mean, has already been taken and it becomes fixed. Okay. So that's what the mathematical approach says, or the intuition. Next, what is left? Now we are left with the standard error of mean and confidence interval. Now let's understand the standard error of mean. What is standard error of mean? Standard error of mean here means that you have taken huge data and then you have taken the mean and standard deviation of that data. Similarly, you have taken several data of the same thing. Okay, I'll tell you. So this is the population, entire population, and now let's suppose I have to calculate height of 1000 people. Okay, so to get accurate value, accurate mean value. But will I do that? Do I have that much amount of time or money to go and measure 1000 people? No, right? What I will do is I will take samples. I'll take sample number 1, sample number 2. Okay, I will take several samples like this, not just 1, 2. I'll take several samples or whatever I can take. That if I want to refine my answers, I'll take more samples. Okay, the more samples you take, the more refined it gets. So sample I'll take, and with that sample I will try to calculate. For the single sample, I will do the mean, I will do the standard deviation. Okay, mean is here this much, standard deviation is this much. Standard error of mean is sigma by under root of n. This also has a derivation that I will tell you later in some videos, or I'll make a short, I guess. So this sigma by under root of n is nothing but, now let's take a random number here. Okay, you can see these are the random numbers. So I have taken the random numbers again, like the height of someone is 155 and height of someone is 193. I am getting mean as 173 and sigma standard deviation is 10.82. So according to the formula, sigma by under root of n. Under root of n means 10 samples. So 10 I have put and 10.82 I have put. I am getting the standard error of mean is 3.42. This is the standard error of the mean. With this standard error of mean, I can calculate something else also called as confidence interval, CI. So the formula for confidence interval is x bar, that is the mean, plus or minus something called as z score times standard error of mean. Now here, what is the mean value? Mean value is 173.1 plus or minus z score. What is the standard error of mean? 3.42. Okay. Now we know this value, I know this value. So these two values are known. What about this value? Z value. From where will I get the Z value? This Z value, like how we have the logarithmic tables. That is a table chart given. You get a value and then you put it in the logarithm table. Similarly, Z value also has a table from where we get the values. We retrieve the values. Like for if I tell, like it is something like this. So this range, whatever I will get here, if I want to say that the mean, whatever the height I am getting, the mean, actual mean is what? 175. If I want to say that I am 95% confident that my whatever the samples height I have calculated, that lies somewhere in between this. It can, what I have calculated can be here, what I have calculated can be here, what I have calculated can be here, okay, whatever it is. But if I say I am 95% confident that whatever the value I have calculated, the actual mean lies within that particular length or range of the data. You're getting my point? So that is the confidence interval. So if I say I am 95% confident about that, then there will be some z score, that is some minus 1.96 and plus 1.96. How do we get that value? There is some graph. Let's suppose here you come. So this is called as normal distribution curve, okay, normal distribution table. So here if you see, this is the actual mean. So in normal distributed table, you will get actual mean as 0 and standard deviation as 1. So see here 95%. If I say 95%, I am confident that my value ranges like the actual mean lies somewhere within my value, then I can so if I say this is my 95% confidence, okay, so somewhere here it is intercepting, somewhere it is intercepting. So this value and this value, so this value will be somewhat like, I think 1.96. This is positive 1.96, this is negative 1.96. okay, this is one tail end, this is one tail end, this is again different thing. This so this is the remaining 5%, and this remaining 5% will be divided into two parts, that is 2.5% and 2.5%. We will not go there. We'll just try to understand the confidence interval as simple as possible. Where did that go? Okay, so if I put the z score, if I want 95% confidence interval, then I'll put here 1.96 or 1.86 something, and then if you multiply that, what was that? Huh, 1.96. So if you multiply that, you will get a range. So you will get some value here. If you add some value, it will go somewhere, like if you, let's suppose 1.96. So take your whole value, take the 5. Here the whole value is 5. So 173 plus 5 is 178. 173 minus 5 is 168. So 168 here and 178 there. So this is the range or the interval between which the actual mean lies. So actual mean is what, 175. Yes, so it is lying. So we are 95% confident that the actual mean is lying here. So similarly, if you take too many samples here and if you draw a graph, okay, then you will see that there is a pattern where majority of the, if you are taking 95% of the, if you are taking 95% of the data 95% of the time, then you will see that yes, the data is lying somewhere in between, okay, and the rest of the 5% of the time, when you represent the data in visual way, you will see that some values are not within the confidence interval, some values are far away from the intervals. Okay, see here something like this. So yeah, confidence. So this is just another example. So let's suppose there is 100 n, that is number of variables, and the sample I have taken x bar. So sample is x bar, and for the population it is sigma. Sorry, population it is nu. So sample is x bar 120 mm of Hg. I am taking here as mean this one, blood pressure. Sigma is 15. So confidence interval, if I am telling, then it is 95. But this is for the population. This sigma is for the population. That means the population sigma is already known here. So I am getting the z value as 1.96. You calculate and you will get this range. See the Q 117.06 and 122. So I am 95% confidence कि for this population the actual mean lies somewhere in between. We don't know what is the actual mean at this point, but yeah, somewhere it is lying in between. But the question here is, the population's standard deviation is known here, but the mean is not known. How does that happen? How can that happen? That can happen if in the history they have already done the value. If they have already done the mean, if they have already calculated the standard deviation, then the data will be there, and from there they are giving us the problems to solve, right? But if I want to take entirely new sample, then we will be not given this population, so we will have to derive the sigma for our own sample. So again we will do the entire thing. For the sample n is 100, so you take the mean, you add all the values, then divide by 100, you will get the mean. You take the deviation, you square the deviation, you will get the standard deviation. Standard deviation is these things. This for the sample. So here standard deviation was not given because this is the new sample, no? Okay, if we have to draw the standard deviation, then this is how we will draw the standard deviation, by taking the mean and all. Okay, so this you will do, and after that you will so standard deviation you have got here, then you will put in the value. Now what is t here? So this t depends on if the number of observation is very less, then the t score is used here. What is t score? What is z score? Z score is for the main population, the big population. N value is more than 30. If you take, that becomes 30 or whatever. If the number of observation is more, then you will take the Z score. If the number of observation is less than 30, then you will use the T score. This is also called as students students distribution, I guess. Students distribution, yeah. So as you increase the number of samples, as you increase the n, T approaches Z. You understand what I am telling? So that is there. Okay, so this is the confidence interval formula that we use. So I think I have covered almost all the things here. But this is just the rough work, don't worry about this. This is rough. So once, if you start playing with all these numbers, if you sit and try to understand, you will understand what is happening here, what statistics is. If you see like this looks very confusing. So we understood till the confidence interval. Okay. Standard of error of mean. Also there is also something else called a standard error of proportion, that we didn't say, but that also we'll discuss in other video. Okay, this was today was holiday, so I got time to make all these notes. Today is Holi also, so happy Holi to all of you. So we understood till the standard error of mean, and we also understood, actually we did not completely understood the confidence interval because it's already too much time. This is the third part and I am done. So I think I will again make one more proper video on confidence interval. Okay, I'll make visuals for understanding what the actual thing it is and how it is used. So we'll talk again about this standard error of mean, confidence interval. Okay, because this is interesting. So yeah, that's all for the video. If you understood even something little, whatever it is, so you can just like the video or whatever you want to do. Bye.
सत्तर में क्या जोड़ा कि 17 हो जाए।
ऐसी मशीन लगाऊंगा, इस साइड से आलू घुसेगा, उस साइड से सोना निकलेगा।
So here you can see